Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we did various numericals based on Gibbs free energy change, and now we are going to do another type of it. So let us do it. So as mentioned on your screen, there is a numerical which is based on Gibbs free energy change. So let us see what are the requirements which are given in the question. So we have to calculate the equilibrium constant for the redox reaction at 25 degrees Celsius, and the reaction is given as strontium plus magnesium 2 plus ion, that gives us Sr2 plus, that is strontium 2 plus ions plus Mg. And in this case we have to write the cell formula also, and the electrode potential, that is standard electrode potential for magnesium and standard electrode potential for strontium is also been provided to us. So let us see that how can we calculate E naught cell. But to calculate E naught cell, we should very clearly have an idea about that which one will act as anode and which electrode will act as cathode. So in this reaction we cannot say, or we cannot predict directly. So let us do a redox reaction and let us check whether the a particular electrode is acting as an anode or a particular electrode is acting as a cathode. So let us take the help of this first. So the reaction that they have provided to us is strontium plus Mg2 plus, that is giving us strontium 2 plus Mg. In this case, the physical state is also necessary to mention, that we could easily predict that this is the solid one, while this is also solid magnesium, but Mg2 plus ion, they are present in aqueous form, while that of strontium 2 plus ion, even they are present in aqueous form. So in this case, if we would see or if we would observe that this strontium is now being converted into Sr2 plus. As you can see, the oxidation number of strontium, which is now 0, which is in a solid form, is now being converted into a oxidation state of 2 plus. So that means it is only possible if strontium has lost electron, and since it has lost electron, so according to this process, this will be oxidation. Well, when we observe our Mg2 plus ion, which is now been converted into Mg, which has a oxidation state of 0. So in this case, obviously that the Mg2 plus would have accepted 2 electrons so as to be converted into Mg, that is magnesium, which has an oxidation state of 0. So this has gained electron, and hence this process is said to be reduction. So by the help of this, how can we predict that which one is anode and which one is cathode? It's very much easy to know that at anode always oxidation occurs. So in this case, which one or which electrode is showing oxidation? Yes, the strontium is showing oxidation. So therefore, the anode on which always oxidation takes place will be shown by the strontium, while that of the magnesium, which is showing a reduction process, and reduction is shown by magnesium. So therefore, the cathode on which reduction takes place, in this case, will be shown by magnesium. So this is how we have predicted that which one is anode and which one is acting as a cathode. So now, because help of this thing, we could calculate what would be the E naught cell very easily. So let us calculate. So the E naught cell, since we know the formula that E naught cell is nothing but the E naught of cathode minus E naught of anode. But recently we have estimated that which one is acting as a cathode and which one is acting as an anode. So in this case, the strontium is acting as an anode while the magnesium is acting as a cathode. So therefore, E naught of cathode in this case will be for magnesium, while that of E naught of anode in this case will be for strontium. And now we could easily substitute the value of E naught Mg and E naught strontium as the value of E naught Mg that they have provided to us is minus 2.37 volt, while that of strontium that they have provided us is minus 2.89 volt. So I could write this thing as minus 2.37 plus 2.89. So let us see what will be the answer of this. 0.52 volt. So this is how we have calculated the value of E naught cell, that is the standard potential of a cell. So this is plus, or this is a value which is in a positive value. So this means the reaction is spontaneous. So these are the few things that we should remember also. So therefore we are going in a very right direction, and let us see what would be the value of the equilibrium constant. But before knowing the equilibrium constant, we should know the formula, or we should know the relation between the E naught cell and the equilibrium constant. So let us see. We know the formula as for relation between the E cell and E naught cell. So E cell has a formula of E naught cell minus 0.0592 divided by n log to the base 10 of product and divided by the reactant. But at equilibrium, the value of E cell will be 0, while that of the log P divided by the concentration of R can be written as log of K, and this K is nothing but the equilibrium constant that we have to calculate. So I could write at equilibrium the overall formula would change into 0 is equals to E naught cell minus 0.0592 divided by n log of K at equilibrium. Fine. So in this case I could write it another way. So therefore E naught cell is equals to, that is, plus 0.0592 divided by n log to the base 10 of K, that is for equilibrium constant. So in this case the value of E naught cell is clearly known to us, which is given as, or which we have calculated as 0.52 volt into, which is equals to 0.0592 divided by n. And what will be the value of n? As we have earlier also predicted that the value of n in this case would be 2 itself, because they have provided us that strontium is being converted into Sr2 plus. This is only possible if strontium has lost 2 electrons. Similarly, if we want to check it for a reaction at cathode, so in this case Mg2 plus is accepting or will accept 2 electrons so as to convert into Mg in a solid form which has an oxidation state of 0. So that means in half cells or in half reactions, the number of electrons that are being consumed or that are being liberated are 2. So therefore the n value will also be 2. So therefore the n value will be 2. And now in this case we have to calculate what will be the value of log K first. So therefore let us see what will be the value of log K. Log K will be nothing but 0.52 into 2 divided by 0.0592. So let us see what is the answer that we could get. So we have got a value of log K as 17.567. This is the value of log of K. But we have to calculate the value of K, that is for equilibrium constant. So this thing can be written as K is equals to antilog of the value which we have, that is 17.567, and let us see what is the answer that we could get. So we have got an answer as 3.689 into 10 raised to 17. So this is the value of the equilibrium constant that we have calculated. So much easy, but too much of vast thinking. So thank you friends for watching this video. I hope you have got an idea that how to calculate this kind of numericals. This was a different kind of numerical in which you have to calculate the equilibrium constant regarding and with a relation with Gibbs free energy. So thank you friends for watching this video. I hope you will share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.